All right, let's get into these examples. So hypothesis testing for means, example 1. A bus company advertised a mean time of 150 minutes for a trip between Denver and Glenwood Springs. A local consumer group had reason to believe that the mean was more than 150 minutes. They sampled 40 trips and found a mean of 153 minutes with a standard deviation of 12.5 minutes. Test the consumer group's hypothesis with a level of significance of 0.05. So they're advertising a mean of 150 minutes. They believe the mean is more than 150 minutes. They sampled 40 trips, and from those 40 trips, they found a mean of 153 minutes with a standard deviation of 12.5 minutes. Test, that tells us we're doing a hypothesis test, with a level of significance of 0.05. All right, so the first thing I want to do is off to the side, I'm going to write mu x bar s n and alpha. Those are the values I'm going to need for this hypothesis test. So mu is the previously stated mean, which in this case is what the bus company is advertising, so 150 minutes. X bar is the mean for the 40 trips, so that's 153. S is the standard deviation, 12.5. N is our sample size, 40. And alpha is the level of significance. So first thing we're going to do is write out the null and alternative. So every hypothesis test starts with an HO and an HA. We're looking at means, so our HO is going to be mu equals, and we're assuming that the advertised time of 150 minutes is correct. And then we want to test that the mean is more than 150 minutes. And I'm looking at my X bar. My X bar is 153. That is more than 150. Is it significantly more? I don't know. Let's find out. Step 2 is to calculate my test statistic. So that's going to be our t-score, which is X bar minus mu divided by S divided by the square root of n. So X bar is 153 minus 150 is mu over 12.5 divided by the square root of 40. If I put the top and the bottom in parentheses, I can type this all at once in my calculator without having to break it up into separate pieces. That way I get the most accurate answer without having to worry about rounding. So 1.518. Step 3 is our p-value. So now we have a new distribution, the t-distribution. So we can't use the normal distribution to calculate the p-value that we're used to. So what we're going to use instead is the t-distribution. So we're going to go into Excel and we're going to use t dot dist. And one of the nice things about t dot dist in Excel is they actually have a .rt so that it will calculate the right tail for us. And when we go into t.dist.rt, let me actually write this out differently. I'm sorry, I'm changing my mind on this. t.dist.rt. First, we're going to plug in the t-score that we calculated. And then we're going to plug in the degrees of freedom. So the degrees of freedom is calculated by taking our sample size minus 1. So over here, degrees of freedom is n minus 1. So our sample size is 40. So our degrees of freedom is 39. So I'm going to do t dot dist dot rt 1.518 comma 39. And this is going to give me the p-value. The t-distribution has a right-tailed test built into it, or a right-tailed probability built into it. And I don't have my Excel pulled up. There it is. All right. So t dot dist dot rt 1.518 comma 39. That's all we need. And I hit enter and I get 0.0685. If I wanted to visualize this, I could draw a bell curve. And this would be one like here. And then this is the area that we just found. So it's already doing the 1 minus for us because of the .rt. I have a small amount of the curve shaded, and I have a small probability for my answer. So then step 4 is to write out my conclusion and my interpretation. So for my conclusion, I need to answer the question, is the p-value less than the alpha? So is 0.0685 less than 0. What was our alpha? 0.05. We want to ask, is it less than, because we want to know, are these results extreme? Are they too small to be plausible? We've already done the right-tailed bit in the probability calculation. That part's done. Now we're asking the question, are the possibilities, nope, that's not what I want to ask. Is this probability too small to be possible? And the answer is no. So we do not reject. The null hypothesis. And then our interpretation says we do not have enough evidence to support the claim that the mean, how did they word this? Travel time? They didn't really word it. The mean time between Denver and Glenwood Springs is more than 150 minutes. So we do not have enough evidence to support the claim that the mean time between Denver and Glenwood Springs is more than 150 minutes. And there we go. There is our first hypothesis test for means.